Hello, everyone, and welcome to today's webinar, Navigating UL1446, Key Insights and Pitfalls for the Electrical Insulation Systems. My name is Steve Alm, the Director of Market Development for the motor market at the Gun Company, and I'll be your host for today's session. First, I'd like to thank everyone for taking time out of their busy schedules to attend today's webinar. Before we begin, let's cover some basic housekeeping tips to maximize the value of your webinar. To ensure the best connection possible, please close all programs or apps that may be using a lot of data in the background to free up your bandwidth. You can join the audio using your computer. However, if you prefer to join over the phone, select telephone in the audio pane and the dial-in information will be displayed. This will also help clear up some bandwidth. Your audio settings will be set to listening only for the presentation portion of the webinar. You can submit your text questions to today's presenters by typing them in the questions pane on the control panel. You may send in your questions at any time during the presentation. We'll collect them and address them during the Q&A session at the end of today's presentation. Any unanswered questions will be followed up with an email after the presentation. If you prefer to ask a question directly rather than typing it, raise your hand and we can unmute you to ask the question. Today's webinar will be recorded and available on demand. Within 48 hours, a link will be sent to all attendees. Without further delay, I would like to introduce Solomon Chiang. Solomon is currently the Senior Technical Fellow at the Gun Company in St. Louis. He has been with the company since 2008. Solomon has held several key positions at the Gun Company, including the Director of R&D since 2021 and Director of Engineering from 2010 to 2020. Solomon began his career with Weidman Canada in 1997 as an engineering manager. He holds a PhD in analytical chemistry from McMaster University. Solomon is actively involved with standard organizations, currently chairing the NEMA Technical Committee for 6IM Insulation Materials Section and serving as a secretary to the IEC TC15 Solid Electrical Insulation Materials. Additionally, he is a voting member of the IEC Transformer Committee and serves on the standard technical panels for UL224 and UL1558. Solomon, over to you.
Thank you, Steve. Good morning, good afternoon, and good evening to our friends from Europe. And welcome back to those who have joined us before. Today, we would like to share some of our experience working with UL1446 files in the past decade, as well as insight from serving at a technical committee with NEMA, IEC, IEEE, and UL. We are not trying to game the UL1446 system or testing. We just want to share some of our tribal knowledge on and experience. As a matter of fact, some UL engineer very often will remind us if he sees us going down the wrong path with UL1446 work, because obviously he doesn't want us to complain to him after spending 1 year and $100,000 of testing. So that's why we call it do's and don'ts. And the topic we are going to cover as below. We'd like to talk about terminology first, and then we would like to explain the difference between thermal class of a system versus RTI or TI of insulating materials. And then we will talk about how to read a UL1446 public EIS system. We will talk about the motor as test to establish a EIS, and then the sealed tube test to expand or modify a EIS. Lastly, we will touch base on Venus and magnet wires, because that is probably one of the more difficult subjects, and it's hidden in the appendix or supplement of UL1446. And the do's and don'ts that we want to talk about would be highlighted in red. Okay, so common UL1446 terminology. The first one, electrical insulation system, EIS. Everybody knows it as EIS. And essentially, more than one electrical insulating material would make it a system together with the conducting part employed in an electrotechnical device. That is a EIS, more than one insulating material. The next one is EIM. That's a little bit new as far as UL is concerned. As far as we are concerned, that's the new UL terminology. But a lot of people still call it major insulation, primary insulation. I mean, that's the way we understand it. And UL's definition of EIM is that the components that the appliance or equipment relies upon to prevent a risk of electrical shock or fire. So that, in a way, is like major insulation. Then the next one, after EIM or NIM, non-electrical insulating material. What UL is saying is that those are essentially components used for mechanical support and protection, and they are not relied upon to prevent risk of fire or electrical shock. A lot of us still call it minor insulation or secondary insulation. Not that we have anything against UL, but we don't want to call it non-insulating material, because if the major insulation fails, that's the one that would save the day, the secondary or minor insulation. And also, in some cases, like barrier between coil, you can use element as a barrier or element board. And in that case, it is classified as a NIM. I mean, element, everybody knows it's a very good electrical insulating material. That's just some of the, a little bit of controversy as far as calling secondary insulation NIM. Okay, the next one down, okay, it's motor. Okay, the technical term for UL is general purpose model. They are the test units constructed according to UL1446 for long-term thermal aging to create new electrical insulation system or substitute and add electrical insulating material to existing EIS. That is a $100,000 test because it's a minimum of 5,000 hours, and usually they 1 to 7 or 8,000 hours. And everybody knows oftentimes it's very expensive. The next one down, the chemical compatibility test, CCL. Actually, that should be CCT because that's a typo. Actually, that's a good one because people call it sealed tube test. I call it sealed tube test myself. But what it is that the sealed tube is the apparatus used to conduct the CCT. And it is a 160-hour aging test of insulating material inside a sealed tube at 25 degrees C above the system class. And it's used to substitute or add NIM, secondary insulation. It's not used for, not typically used for EIM. So it is used to add NIM if needed. I'm going to talk about sometimes you can add secondary insulation without any test, but that I would save it for almost last. Okay, the system class or thermal class. When we say system class or thermal class, it refers to the electrical insulation system. That is the temperature class assigned after the thermal aging, the long-term thermal aging. And the common terms, people call it many different ways. System class, thermal class, temperature rating. Sometimes they even call RTI, TI. Actually, RTI, TI technically refer to the material, not the system. And that is done using a different thermal aging, UL1446B, but still people essentially use those terms interchangeably between the system class and the material RTI. I mean, we kind of understand if you say the 220C temperature class, we know what it is, whether it's a system or material. But one thing that I want to highlight that's very important is that the temperature class or material in an EIS, in an electrical insulation system, they do not need to be same or higher than the system class of the EIS. Why? Because, as I mentioned before, it's actually two different types of thermal aging. 1446 is for the system. SAM 46B is for the polymeric materials. And even though they use the same Hinner's principle of activation energy, it's different tests. So I'm not the only one who say it. We are not making this up. The standard say so, but sometimes very hard to find. So if you look at the IEC standard, basically the second paragraph essentially is saying what I just said. It does not need to be the same. The relation of EIM to EIS. NEMA says the same thing. The last paragraph, essentially, electrical insulating material can be different. Okay, NEMA use RTI for both. Okay, RTI for the material and RTI for the system. Essentially, they can be higher, they can be the same, but they can be lower. So what that means is that if you have a 220C system, not all of your material, they don't need to be 220C. They can be 220C, they can be 240C, they can be 200, they can be 180. Even UL say the same thing in page 16 of 1446. Essentially, they are telling you that it can be either higher or lower. The insulating material can have different RTI than the temperature class of the system. So all three standards are saying the same thing. We have a lot of confusion. People are saying that why are you selling me a 200C material for my 220C system? Essentially, UL say so, NEMA say so, IEC say so. They are not the same. I mean, as far as the test methodology is concerned, NEMA is most direct by saying that it applies to both major and minor insulation. IEC's EIM cover both EIM and NIM in UL talk, so that's where some of the confusion come from. And even UL, I mean, they create the EIM and NIM under glossary, but then they forgot to go back to the remaining tests and change them over. So if you read 1446, the front of the standard says one thing, and then later on they revert back to call it insulating materials as generic term without saying whether it's both EIS, EIM, or NIM. Okay, so much for UL. I mean, we do the same thing. Sometimes we revise the standard, and not every page got revised. Okay, at this point, we would like to do a poll question.
All right, the poll question's coming up. Here we go. Have you had any experience with UL1446 electrical insulation systems? Please go ahead and make your selection. Looks like we're getting results about 77%, 80% on no.
Okay, so hopefully we will be able to address this at the end of the presentation. Now, After the glossary and explaining the difference between electrical insulation system and electrical insulating material, and then they don't need to be of the same temperature class, then we'll go back and do a deeper dive of UL1446. And for those of you who have gone to the UL site, the UL Portal IQ, and look under the electrical insulation system and look at some of the system, they look kind of quite overwhelming. Yes, they are not the easiest to read because a lot of them, they've been developed over 50 years, and the wording and the details can be kind of inconsistent. An old system may look a little bit different than a new system in terms of format and the arrangement of the groups of components. So what I'm trying to do is to go through a system from top to bottom. Magnet wire is used to generate magnetic field. We all know that the magnet wire insulation, obviously, is right against the conductor. It's always a major insulation. They are usually found on top of at the front of a public EIS. There are two types of magnet wire. The enamel wire that we are all familiar with, the one with polymer coating. And then what we call the wrapped wire. They are essentially 2 mil element wrapped conductor with 50% overlap that make it 4 mil. And the magnet wire are usually listed at the top of a public UL1446 file. And it will look like that. Now, and if you look at the UL1446, for 220C high voltage system, all you will see is wrapped conductor because they only allow the wrapped conductor, element wrapped conductor in a 220C high voltage system. For non-high voltage system, then sometimes it has element wrapped conductor also, but from time to time you're hired underneath enamel wire, then you start scratching your head. This is not enamel, but that's the way it is. So if you cannot find a wrapped conductor, look under enamel wire and see if you find a wrapped conductor there. Okay, so after the magnet wire insulation, then the next one that you will find is called ground and interwinding insulation, sometimes called high-low. They are always major insulation. And ground means any bare metal, doesn't need to be the true ground. And the interwinding, sometimes called high-low winding. Okay. And usually those are the typical ground and interwinding insulation. DuPont, we all know, Nomex, the gun company, G-Flex, VM. And in a North American system, usually that's all you find from 3 companies. The major insulation and the varnish need to have UL yellow card. They need to be UL recognized. And then after major insulation, you will see what they call minor sheet materials, or minor sheet insulation. And usually there are many other choices. So it is not the DuPont, the gun company, VM only. You can see some Isovolta, One Row, USA, even Picaro. So those are called minor sheet insulation. So, and even if you don't find it there, by rule is that any major insulation available in sheet form can be used as minor insulation. And minor insulation does not need to be UL recognized. Sometimes UL will put the file number, sometimes they forgot to put the file number, sometimes they don't have the file number. So the fact that one has a UL one minor insulation has a UL file number, the other one doesn't mean one is better than the other. I mean, they don't need to be UL recognized. They just need to be tested together in the sealed tube. So that's minor sheet insulation. And then afterwards, you will find tapes, tubing, sleeving. There are all kinds of choices. 3M tape, intertape, ideal tape, tube and sleeving, usually AMP, Delphingen, and then even Jerome High-Tech, Sanovo. So those are always minor insulation. And then spacers and wedges, it can be from the gun company, it can be from our competition. Those are spacers and wedges, high cord, overcoat, potting compound. Those are all minor insulation. Essentially, they don't touch the conductor. Core tubes and bobbins, they are minor insulation unless there's nothing in between them and the conductor. That only happens with very small transformer. The one that you use copper foil as a conductor. The copper foil may be against the core tube. Then make the core tube major insulation. Okay, lead wires are usually minor insulation, but in the old days, for small transformer used in a TV, you can actually use inexpensive filament wire as a magnet wire. And when you look at some of the public UL system, you see filament wire leads on top and enamel wire, and those are cheap 3122 wire. What that means is that you are looking at a system that inherits those lead wire from the original system. Doesn't mean you want to use it. They don't take too much heat. And there are all kind of transformer profile that tells you what gauge or lead wire that you need to use in a transformer anyway. But that's where the confusion comes from. Because they got inherited in the original system, so you see all those inexpensive filament wire there. Varnish are considered of major insulation, but I'll talk about that later. I mean, they can be substituted or added without thermal aging under certain provision. And usually, you see the varnish at the end of the public UL1446 file. And the varnish and the magnet wire need to be reviewed together, because you have to look at what the varnish is allowed in this system, and then you have to read the fine print in the comments. I will talk about the comments later on, but the point is that the varnish and the magnet wire, they need to be considered together all the time. Okay, the next one that I want to talk about is the motor test. What a motor test is the technical term is a full thermal aging. And what it is that a motor is the test module, the general test module, and they are being aged at 3 separate temperatures. And then there are diagnostic tests to determine how long it takes for the motor to fail, usually based on leakage current. And in a webinar about 2 years ago, we talked about the methodology of motor test in more detail, but so I won't go through the detail here. But the important thing is that at each temperature, the geometric mean of the hour to failure is obtained, then they are plotted. And using the plot, you can determine the what we call apparent thermal index in Celsius by extrapolating it to 40,000 hours. So the temperature, so at which, so the 40,000 hour cross over the 40,000 hour point is your apparent thermal index. That is a high bar, because if you don't want to use a control, then you need to meet 40,000 hours. but most of the time, I would say 99% of the time, the motorized test is done with a control. And control motorized come from a known and established system. So what you do is that you age your motorized constructed according to the candidate system and the control system side by side, and then you compare the performance, the thermal performance of the candidate motorhead to the control motorhead. And then I will demonstrate in the next two slides, you can either graphically compare the performance of the control motorhead to the candidate and determine the thermal index that way, or you can resolve the EIS equation mathematically. Okay, there are rules as to what control you can select, and essentially it needs to be within 20 degrees C of your apparent thermal class of the candidate. So if you think you have a 220 C thermal class candidate, then your control needs to be 200 and 220 or 220. It cannot be 180 because that could void the test result mathematically because it's too much of a gap. The aging temperatures usually 20, 40, and 60 C above the known and anticipated thermal class to provide minimum end of life hour. So if you're trying to shorten the test at a higher temperature, then your test is invalid because you do not reach the minimum end of life hour. Again, I would explain that principle in the next 2 or 3 slides. And the EIS equation is right below the picture of the motor. E is your activation energy. K is your rate of thermal degradation. The higher is activation energy, the slower is your rate of degradation. And if you look at, okay, these are actual thermal aging results, and this came from a UL report, so obviously I have to black out the control system and the candidate system. On the left-hand side, it's the control system. On the right-hand side is the candidate system. As I said, I need to black out the name of the system. And one thing that you will notice is that the slope of the candidate is much higher, steeper. Here has a high activation energy. And as a matter of fact, the candidate system is so good that if we stop the test at 7,000 hours, and at that point, we can already extrapolate to 221 C at 40,000 hours. And we still have 6 out of 10 motorhead surviving. If we let this thing keep going, this thing will probably finish at 8 or 9,000 hours. We will probably get about 235 C. But we don't need 235 C. All we are looking for 200 for this to be established, a 220 C system. So we stop the test there because 7,000 hours, including diagnosing test, is already 10 months. We don't want to spend another 3 or 4 months on it and waste all those time. So the control die, all the control motor die at just over 5,000 hours. So what we do is that we use the 220 C control system, and based on that, we come up with a correlation hour of 16 to 65. We take that correlation hour, move it to the candidate, and then we got the 231 C. We got 231 C as the apparent thermal index of the candidates. And that's one thing that I want to share with you is that the UL allowed you to discard outliner in your test result. If you look at it, there's one outliner in the control. It has a premature failure, and statistically, it does not belong to the same population of the other. And also, you can look at the construction, and then that is probably due to a poorly constructed motorette. So UL do allow people throwing away bad results with good statistical and objective evidence. So that's something I'd like to share with you guys. If you are conducting motorette tests, if you have one bad one, you can talk your way out of that one. And also, but then UL also has some rule. Your correlation, coefficient or correlation of your data point need to be at least 0.95. Okay, so if it's less than 0.95, that's too much scatter with your data point. UL would not recognize that heinous curve. So if you already spent 5,000 hours on it, that's a lot of money down the drain. So I will show you how to avoid that. So that's graphically. Actually, right now, UL doesn't even bother to do it graphically because this is a lot quicker, a lot more precise. Mathematics just resolve the image equation from the graph. If you can get slope and intercept, you use the slope and the intercept as well as the apparent thermal index of the control, the big T. Then you can resolve the small t. The small t is your correlation hour, and then plug your correlation hour back into the candidate along with the slope and intercept of the candidate, and then you get the apparent thermal index of the candidate system. And in this case, it's 231.3 degrees C. And one reason why UL would use the software mathematics, they want to look at your correlation coefficient. In this case, 0.995, 0.998, no, 0.995, 0.988, no problem. They have good correlation. So this is acceptable as far as being the both control and candidate. So this is a good result. Now, this is something I want to share with all of you. We all know that UL's system class go up in from 180 and up is an increment of 20 degrees C. So even though we have apparent thermal index of 231 C, we don't get 231 C, we don't get 230 C, we get 220 C. The lake lowers. So you may say it's unfair. Yes, it's unfair, but that's the way it is. So, but what it means is that within the same class, like a 220 class, apparent thermal index of different EIS can differ by almost 30 C. Think about it, a control system that's at the top of this class will be a high bar for a candidate system to benchmark. So what that means is that a lot of pre-screening testing and planning are important. Otherwise, a good UL engineer will guide you to do pre-screening and test planning. Even as I mentioned before, if you don't select your aging temperature accordingly, for example, the rule is that it's 20, 40, and 60, the C. But if in your pre-screening, you find out that you may not get the 5,000 hour at the lowest aging temperature and 1,000 hour at the highest aging temperature, you may want to think about it, and you may want to talk to your engineer. The last thing you want to do is to spend 3,000 or 4,000 hours, $60,000, and find out that there's no hope in hell. You would get the system class that you are hoping for. So pre-screening, selection, and essentially be very careful because this is a $100,000 test. Now we have our second poll question.
1 second, getting ready to launch. All right. Have you adopted and modified a UL electrical insulation system? Please go ahead with your answers. All right, results are coming in. Looks like about 44% on no, up to 50%, 33% yes, I've adopted a UL insulation system. And a couple more responses. All right.
So we have a very balanced response.
Yep.
So now we are going to talk about sealed tube test. And okay, first, what's the difference between full thermal aging and CCT sealed tube test? Full thermal aging motor is usually used to establish a new EIS from scratches. It can also be used to substitute or add major insulation to existing EIS. But if after spending $100,000, you may as well give it a new name. As a motor end, as the picture shown before, they can only hold a few minor insulation beside the major insulation and varnish. Table 1 of a newly created insulated system is usually very bare bone. If table 1 is fully loaded, it came from and the EIS and renamed. So this is how you can tell if an insulation system has a very bare bone table 1, it's a new system. So once you create a bare bone table 1, then you add other minor components. You add more varnish using the chemical compatibility test with sealed tube method against the control of reference. And as I mentioned before, for new EIS, the control is the bare bone. And then the CCT can also be used to substitute or add minor insulation from any public UL system by absorb and modify. And then the control, UL will usually help you to select the control. Usually the control comes from the origin of the adopted system. And in general, add is better than substitute because you have more choices. But within reasonable sealed tube components count. I'll talk about why that is important later. Well, this is the sealed tube. So what you do, again, in a previous webinar, I described it in a bit more detail. So this is just a rough description of how a sealed tube works. This is also an accelerated test for substitution or addition of minor insulation. You can use it for varnish also under a certain condition. Each varnish needs a separate candidate tube. They are aged at 25 degrees C above the EIS thermal class. So if you want to add something to a 220 C system, they are aged at 245 C. So what it is that the outgassing from the various material inside the sealed tube would attack the varnish and enamel insulation on the trace wire. There's a table here, and then all the varnished element wrapped the wire. And what happened is that how do we know how much the wire has degraded? Well, we do the dielectric test of the wire insulation will determine dielectrical strength of the wire insulation will determine before and after thermal aging. The rule is that the degradation of the wire insulation in your candidate cannot be more than 50% of the degradation of the wire insulation in the control sealed tube test. I think it can be no worse than 50%. So 50% is good. 49.9% is no good. No worse than 0.5 or 50%. So that's the rule. Now, I'm going to share some hints about how to make sure that you have a high probability of passing a sealed tube test. Number one, I want to share with you is that some minor insulation can be added without even any sealed tube. Minor insulation that are chemically equivalent UL fingerprint can be added or substituted without test. No test update work at UL is $2,000. Why? Well, UL1446 SA3 say so, right up there. So if it's chemically equivalent, then you don't. You just substitute. And as long as you get what we call a UL letter report based on fingerprinting, and this is, again, I had to black out the name of the grade. Essentially, N060308 is the fingerprint of the candidate, and N060408 is the fingerprint of the control, the material that you want to substitute. And they say conform. So then UL will write you a letter. Grade X is eligible to be substituted for grade Y as minor component of insulation in a previously evaluated insulation system. Done. No test. $2,000. We have a couple of recent examples. And then, okay, fine, if the fingerprinting doesn't match, and actually UL is getting quite strict with fingerprinting, so it's very unmatched, so most of the time they don't match. So then we had to do a sealed tube test. What to pay attention to, as I said before, CCT is essentially testing corrosion resistance of the varnish enamel or element web wire against outgassing. So the more from other components, the more components you have, the more they outgas. So the rule of thumb is that keep it down to 60 to 80%. Okay, because the control tube usually only contain no more than 10 or 12 components. So in order to match the performance of the control tube, don't be too aggressive. And below is one example. The first example is a sealed tube test with over 300 components. And we only have 4 varnish family that's equal or better than 50% threshold. We take the same same system, chop it down from 300 to about 140 components. A family pass the threshold. And we are going to do it again. Next time we will chop it down to about 60 to 80. And I think all 13 varnish family will pass the test. Obviously, this is a very aggressive universal system. And you can write to us and we'll tell you which system it is. It would have 13 different varnish family to use and a lot of components. Now, and another tips that I want to share, and actually from time to time, the UL engineer will tell you, I mean, a lot of the time the control system come from the origin, where the origin of the adopted system. And it may have some really old and strange component there. Even though UL allowed you to remove those from the control system, and like the filament wire, because you cannot find it, a UL engineer will tell you, watch out, the more stuff you remove from the control system, it is already bare bone. It make it harder for your candidate to meet the 50% high bar. And the other thing that I want to mention is that the sample preparation. Yes, when you tell UL you are going to, for UL1446 has rule as to the sample size for the sealed tube test. For example, 1 inch square for sheet material, 1 inch length for lead wire, sleeving and tie cord and things like that. They don't say anything about thickness. Try not to put a big hunk of copper, no, big hunk of rubber as you're sleeping, because the next page tells you why. Avoid adding heavy components known to release a lot of corrosive tests, natural material, rubber, and bright pigments. So those are the ones that tend to be corrosive, affect your sealed tube test of your candidate system. And also, use equivalent system to reduce components count and avoid unnecessary sealed tube tests. I don't know if you can see it. Left-hand side is a VM tape. Right-hand side is the inter tape. I mean, if you want to use, if you want a certain use VM tape and look at the system, and it is, and that tape is already there as an equivalent tape. Don't need to do CCT. This one is your get out of jail card. You can use the VM tape already because VM already have done the fingerprinting to come up with all these equivalent, just like what we did in the example we showed you before. So we are up. We still have a couple 5 more minutes. And I would finishing off. I have a few more slides. Okay, the first one is varnish and magnet wire. And as I said before, the magnet wire is listed at the top. The varnish is listed at the bottom of the electrical insulation system. Not every magnet wire can be used for the varnish listed. And the reason, and if you look at the this system, it has 12 different varnish family. You have to look at the comments. The comment will tell you which type of magnet wire you are allowed to use. If you don't see any comments, that's good because look at ISO 51, no restriction. Any magnet wire listed in the in this system can be used. Why? Some have to do with the testing result. A lot have to do with the varnish itself, the yellow card of the varnish. If you look at it, those are the yellow card of the varnish. I won't go through it in detail because I'm not the subject expert on varnish. Essentially, the yellow card shows the varnish and what type of magnet wire has been tested to. Essentially, you are looking for a varnish with a lot of choices of magnet wire, also with a lot at high temperature. So if you see all those 220, 240, those are good varnish. Okay, if you don't see it and you have a high you have a 220C system, then that means that you have to think about some other varnish. And lastly, UL consider varnish as a major insulation, but then the varnish can be substituted or added either without any testing if they are chemically equivalent, as I shown before, or use sealed tube tests. In a lot of cases, I mean, I won't go through all the rules, but the rules are somewhat hard to understand. But in a lot of cases, if you pick a good varnish with a lot of magnet wire selection and a varnish with a good history, chances are you can substitute, you can add that varnish to your existing system with a sealed tube test without going to single point thermal aging or full thermal aging. And okay, I'll just cover this one briefly. Some of you have already seen it. If you want to add minor insulation to a 220C and 220C high voltage system, from time to time, you find that UL asks you to use this varnish in your control tube. This is Dalconing. This is obsolete varnish. We know how to get it, The reason why UL asks you to use this one is because this one is in the very origin of a lot of old system going back 30 years. Okay, TGC, we do have our GFLEX electrical insulation system for customer to adopt. You can either use it as is, or you can adopt it and give it your own name. The cost of adoption is only $4,000, and that means you adopt it and as is without making any changes. If you say that there's something missing there, or we do not have all the varnish that you like, and the cost of modification, like minor insulation, is only $8,000 for one varnish family. So for each additional varnish that you want to use, that is another $4K. So they are not super expensive. And TGC, we may even bear the cost for you to adopt as long as you like to use our material, our minor insulation and our major insulation. So you can consult the account manager assigned to your account. Even if you don't like our system, you want to use yours or you want to use someone else, but then you don't want to do the work, you can sign, UL have that an L37 agency agreement. We can be your agent. Just a couple of papers to sign off by UL, and then we can do everything. You can do turnkey for you. We can do the testing. We can do all the paperwork, and then we will not even see your system once it is complete. So that agency is temporary. Again, we could cover the cost also, completely turnkey. Again, you had to talk to our salesman. We like you to use our material, either the minor insulation, the spacer and wedges, and the major insulation, which will be our GFLEX material, including our GFLEX element and our GFLEX element, minor element laminate. So thanks for your time. And as I said, all those do's and don'ts, we are not trying to game the UL1446 system or testing. We just want to share some tribal knowledge, experience with you. Sometimes your UL engineer, if they see you going down the garden path as far as coming up with your candidate tube loading or control tube loading is concerned, they will remind you also. Obviously, if you are doing a motor-ed test, they don't want you to complain to him after you spend $100,000 and 1 year not getting what you want. So I guess it's now time for questions.
Yes. So thank you, Solomon. For those of you here today, we'll have some handouts that will be available to you to download. There'll also be some comparative data sheets showing properties of different materials that we may have talked about here today. And also you can find other comparative data sheets and other information up on our website. There'll be a link put into the chat and also sent out with the email. So questions from here, we'll be taking a look at any questions that were submitted before the presentation. As a reminder, if you have any questions, you can put them up in the Q&A. We'll start out with one that came out from prior to the meeting, actually. Solomon, you mentioned the timing on the materials. Like you have a system that's very old. You mentioned some of the systems that are very old that have the control systems. What is the process they have to do if they want to add or update a product that's in that system? Like it's a customer or a supplier who's either not in business anymore or the name of the business has changed. UL will keep, if the material is UL recognized, UL will keep track of all the merger and acquisition. But then if you are talking about minor insulation, that does not have a UL yellow card, then you have to convince that this from ABC company is the same as the XYZ company. So you have to convince UL. And depending on which UL engineer you are dealing with and how familiar you are
with that UL engineer. Then you have to provide some objective evidence that this XYZ material is the same as ABC material. And then sometimes they take your word for granted if you have a lot of internal data, including fingerprinting. If they are not too sure, they will ask to do a fingerprinting test. Fingerprinting is not that expensive, $2,000 or $3,000.
Okay. Thank you, Solomon. There was another question posted in the link from Bruce Lyle asking about the article that you discussed about the thermal aging. The link is up in the chat as well to answer Bruce's question, and we will provide that into the email that goes out as well so everyone has access to that. Does anyone have any other questions? All right, just want to say thank you again, Solomon, for today's presentation. Thank you to everyone for attending. If you have any other questions, please contact us via email or by phone. You'll receive a brief survey and a follow-up email with all the recording links and any links to information that we mentioned here today that we'll be providing to you. On behalf of the gun company and our presenters, thank you for joining us today and have a great rest of your day.